In this video, we will graph a function using Desmos.com and then analyze the graph to determine whether the function is increasing or decreasing, as well as determine any relative extrema. To determine where a function is increasing or decreasing, we want to read the graph from left to right, just like we read a sentence in a book. If the graph is going uphill from left to right, the function is increasing. If the graph is going downhill from left to right, the function is decreasing. So looking at this first graph from left to right, notice how the graph goes uphill until we reach the x value of -2, and then to the right of -2, the graph goes downhill, and therefore the function is decreasing. So we can say the function is increasing when x is less than -2, or using interval notation, the function is increasing over the open interval from -infinity to -2. And the function is decreasing when x is greater than -2, or using interval notation, the function is decreasing over the open interval from -2 to infinity. Now looking at the graph below, again reading from left to right, notice how the graph goes downhill, reaches a low point, and then starts to go uphill. And therefore the function is decreasing when x is less than -2, or over the open interval from -infinity to -2, and the function is increasing when x is greater than -2, or over the open interval from -2 to infinity. And now let's talk about relative extrema. Wherever a function changes from decreasing to increasing, and the graph has a low point, this low point represents a relative minimum. And there are a couple of ways to express this information. Sometimes we'll see the relative minimum expressed as an ordered pair, in this case -2, -4, or more specifically we can say the function has a relative minimum of -4 at x equals -2. Notice the relative minimum is really the y value or function value, and the location is the x value. Similarly, where a function changes from increasing to decreasing, we have a high point on the graph, which represents a relative maximum. As an ordered pair, we have a relative maximum represented by the ordered pair -2, 4, or more specifically, we have a relative maximum of the function value of 4 at the location of x equals -2. Let's look at our first example. Graph the given function to determine the open intervals for which the function is increasing or decreasing. Use interval notation. Then determine any relative extrema. We are given f of x equals -1/4 x squared minus 3/2 x minus 1/4. Let's go ahead and graph the function using Desmos. To do this, we open a browser and go to Desmos.com. Then click Start Graphing. We will enter the function in number 1. We will use y instead of f of x. We can enter the function from the keyboard or the Desmos keyboard by clicking the keyboard button in the lower left-hand corner. Let's go ahead and enter the function using the Desmos keyboard, and therefore we enter y equals, for negative we use the minus sign, so -1 divided by 4, right arrow to get the cursor out from the denominator, x squared minus 3 divided by 2, right arrow, x minus 1 divided by 4, enter. Now that we have the function entered, let's close the keyboard by clicking the keyboard button again. Notice how we have a nice view of the graph. If we want to, we can click, hold, and drag to reposition the graph. If we wanted to adjust the window manually, we would click the wrench, adjust the x-axis here, and the y-axis here. We can also zoom in and out by using the plus or minus buttons here. But since we already have a nice window, let's now click on the graph. When we do this, key points on the graph appear in gray. We have the intercepts as well as this high point here, which represents a relative maximum. Let's go ahead and click on the relative maximum and notice how the ordered pair appears of -3, 2. Where the relative maximum value is 2, the location is x equals -3. And now let's read the graph from left to right. Notice to the left of -3, the graph is going uphill from left to right, and therefore the function is increasing when x is less than -3. To the right of -3, the graph goes downhill, and therefore the function is decreasing when x is greater than -3. And now let's go back to our work and record this information. Again, we had a relative maximum at the ordered pair -3, 2. Because this high point is the highest point of the entire graph, we can classify this as an absolute maximum or just a maximum. And therefore we can say that f of x has a maximum of the y value or function value of 2 at x equals -3. And now for the intervals for where the function is increasing or decreasing, let's use a number line. If we plot -3 on the number line, because that's where it changes from increasing to decreasing, we make an open point. Again, looking back at the graph, when x is less than -3, the function is increasing. When x is greater than -3, the function is decreasing. So it's increasing on the left and decreasing on the right. As we move to the right, we approach infinity. As we move to the left, we approach -infinity. So the function is increasing using interval notation over the open interval from -infinity to -3. And the function is decreasing over the open interval from -3 to infinity. Let's take a look at one more example. Same question, but now our function is f of x equals 1/4 x squared minus 2x minus 1. So going back to Desmos, let's go ahead and clear the function in number 1. So we'll bring the keyboard back up and click the delete button and enter the new function. So we have y equals 1 divided by 2 right arrow x squared minus 2x minus 1. Enter. Let's go ahead and close the keyboard. Again, we have a pretty good window already. Let's click, hold, and drag to reposition the graph. And now we click on the actual graph and the key points appear, meaning the intercepts as well as this low point, which is a relative minimum. Let's click on the relative minimum. We can say the function has a relative minimum of -3 at x equals 2. And now reading the graph from left to right, notice how the graph goes downhill when x is less than 2, and therefore the function is decreasing. Then the graph goes uphill when x is greater than 2, and therefore the function is increasing when x is greater than 2. So going back to our work, again we had a relative min represented by the ordered pair 2, -3. And again, because it was the lowest point of the entire graph, we can classify this more specifically as an absolute minimum or just a minimum. And therefore we say f of x has a minimum of the function value or y value of -3 at x equals 2. And the function changed from decreasing to increasing at x equals 2. So if we plot 2 on the number line and make an open point, again to the left of 2, or when x is less than 2, the function is decreasing, and when x is greater than 2, or to the right of 2, the function is increasing. So the function changes from decreasing to increasing at x equals 2. To the right we approach infinity, to the left we approach -infinity. So we can say the function is increasing over the open interval from 2 to infinity, and the function is decreasing over the open interval from -infinity to +2. And again, it doesn't ask, but we could also say the function is increasing when x is greater than 2, and the function is decreasing when x is less than 2. I hope you found this helpful.